Howdy students, it's Bowles, and I want to work with you on doing some problems in stoichiometry. Last time you guys worked on mole to mole problems where you used a mole ratio. And so I just want to remind you that you need to use a balanced equation always, and it will allow you to form amounts of products and reactants based upon the ones you started with. And now the coefficients that you're using are going to be what are called mole ratios. Remember, mole ratios come from the balanced equation. It means 2 moles of aluminum oxide makes 4 moles of aluminum and 3 moles of oxygen when you allow it to decompose. With that, you end up with the following ratios from the equation when you relate each to the other, and also their reciprocal is possible. So there's a total of 6 mole ratios. So now when you begin to think about stoichiometry from your balanced equation, like this one, you can find any substance that's in the equation from any other one given. And I like to set my 2 mole charts next to each other so that I can realize to get from moles of one substance to moles of another substance, I merely have to use something called the mole ratio. And the mole ratio is always what I want over what I have in order to cancel the units of my given. This chart is going to come in handy, and you'll use it to find your way in solving these problems. So I'm going to do 2 problems with you today. Here's the first one. C3H8 plus O2. Notice here that the equation is not balanced. So the first thing you need to do is balance the equation. So counting the atoms, I have 3 carbons here. I need to have 3 carbons here. Right now there's only 1, so I'm going to go ahead and put a 3 here. I also need 8 hydrogens on both sides, and this side only has 2. So 4 times 2 is 8. Remember, the arrow acts as my little balancing. I need the right and the left to have the same number. Now I just need to get the O2s. I have 2 O2s, 2 oxygens here. 1 times 4, that's 4 oxygens, and 2 times 3. So here are 6 oxygens and 4 oxygens, a total of 10. On this side I need 10, which means 5 times 2. So my balance equation is 1543. Now, let's go ahead and follow the same format we've been following in class. Let's underline the given and circle what we're looking for. So read through the problem, calculate the moles of CO2, circle what you're looking for, and underline the given. Then take the given and put it on the upper left, just like we always do, of our picket fence. Okay? Make sure you write what substance it is, because we're going to be switching substances. Now, if you notice, this problem requires you to go from grams to moles. So at the end, we want to end up with moles of CO2 at the very end of this problem. Are you thinking about how you're going to get there? The units here need to be grams to cancel. But look at your big mole chart. We're starting with grams of something, and we need to get to moles of something else. So we're going to need to divide by the molar mass and use that mole ratio to get there. That's the plan. So let's go back. So first thing, divide by the molar mass of the C3H8. So I need to quickly calculate the molar mass of C3H8. So I'm going to count up my carbons. That's 12 times 3 is 36. Hydrogens are 1, and there are 8 of those. So it's 8 for that one. So 36 plus 8, that's 44, isn't it? 36, 44. 44 grams is the molar mass of 1 mole of C3H8. So if I do that, I just cancel my grams, and now I'm at moles. But remember, I am at moles of C3H8. So here I am. I just did this part. I got to moles of C3H8. Now I need the ratio to get to moles of my new substance. So let me go back and do that. So now I have moles of C3H8. This is where my ratio step comes in. Remember, the ratio is what you want over what you already have. The want over the have. So when you think about that, I want to get, look at my circle, moles of CO2. So that's a 3. I want moles of CO2, so I'm going to put 3 moles of CO2 on the top because I want that. The stuff I've already got is the C3H8, and look what it says, 1 mole of C3H8. So when you do that, you're going to cancel the moles of C3H8, and you're going to solve now for moles of CO2 because that's what's on the top. Everything else is canceled. So now, just looking at the math here, let me see if I can change my colors real quick. I don't think I'm doing it. Looking at the math, it's 28.9 divided by 44, up here's just a 1, times 3. That's going to give you your answer. 28.9 divided by 44 times 3. I don't have that number right now, and my calculator is not in my hand. So let me switch to the second problem I want to show you, and you go ahead and calculate that one for yourself. Here's the second problem I want to show you. Notice this equation is already balanced. When you don't see a coefficient, it's a 1. So let's do the same thing on this one. Let's underline our given and circle what we're looking for. Underline our given and circle what we're looking for. So my given always is going to go on the upper left of my picket fence. And remember, I need to cancel the units of my given so I know it's going to be grams. Do you want me to show you that mole chart again so you can take a look? Look what I have. I have grams, and at the end, I want to come up with grams of O2 at the end of this problem. I need grams of O2, but look, I started with grams of H2O. How am I going to get there? I don't think I have my mole chart. Let me go back. Here it is. So I'm going to need to go from grams of what my given is to moles, then the ratio, and then from moles to grams. Take a look at how that's going to go. It's going to require 1 step, 2 steps, and 3 steps. These are the hardest problems in all of stoichiometry where you need 3 steps. Gram to moles, mole ratio, mole to grams. So let's do it. Grams to moles. So you know I'm going to divide by the molar mass of water. Well, O is 16 and H is 1 plus 1. So that one's an easy molar mass. 18 grams in 1 mole of H2O. Got it. Grams cancel. So I've already done my first step. I've converted to moles of water. Now I need to go, and this is going to be my mole ratio. So I want over have. All right, what do I want? Well, I circled what I was looking for. I need to get to O2. So over here for O2, my coefficient is 6, and over here for H2O, it's 6. So it's 6 moles of O2 and 6 moles of H2O. Why did I set it up that way? Because I have moles of H2O up here, and they're going to cancel. So now I've moved. That's what the ratio does for you guys. It allows you to change from anything in the equation to any other thing in the equation, which puts you on your road to crossing to the new substance. So now I have moles of O2. My last step is going to be taking the moles of O2, 1 mole of O2, and converting it to grams. So I need the molar mass of O2 now, which is 16 and 16, or 32 grams. So in order to solve this, what I'm going to end up having for math is 21.3 divided by 18. Now, as far as this 6 over 6, I can reduce that to 1 over 1. If you want to leave it in for the math, you can, but the math would simplify if you reduce it. So the math again is 21.3 divided by 18, 1 over 1, so nothing, times 32. That's going to give you your answer. So you calculate that, and that is how you do it. Those are your mole problems. Stoichiometry, it's all there. You got this.